Today we're taking a look at compound interest formulas. Now there's a couple of formulas that we're going to use. The first one here is for annual compound interest. That means we're going to take an amount of money, we're going to deposit it into an account that's going to earn a certain percentage of interest over the course of that year, and it will be compounded and added to that account once that year. So that formula reads like this: the principal amount, that's what you begin with, that's your initial deposit, times 1 plus our interest rate. Now that R is going to be a decimal rate. Typically they give you an interest rate in terms of a percentage. You need to change that percentage to a decimal. And we're going to add that to 1. So this will now be a number over 1. And that number is going to be raised to the t power. So t is going to represent the number of years that money is deposited earning that interest rate. Now there's another compound interest formula, and this is called the general interest formula, and this is going to be used in times when we're compounding our interest more than once per year. So it goes like this: P, our initial amount, times 1 plus our rate divided by n. Now this n represents the number of times it's compounded per year. However, that n is also used in our exponent. We'll multiply n by t, the number of years that money sits in the account. All right, now the annual percentage yield just represents this term that signifies the interest earned after all the compoundings have taken place for a year. So compounding amounts. If we do it annually, that means we're going to compound it once per year. Semi-annually is twice, quarterly is 4, weekly, well, there's 52 weeks in a year, monthly would be 12 times per year, and daily ranges from 360 to 365. All right, now these would all be our different values for n, and this formula up here for the general compound interest formula. So have your calculators ready. We're going to go through a few examples. All right, example 1 says to find the APY, annual percentage yield, for a 4.5% interest rate compounded semi-annually. So again, here is our n value is equal to 2. We see our interest rate R is 4.5%. Now as a decimal, that's 0.045. So to calculate annual percentage yield, we're going to let our principal amount just be $1. And we're going to say 1 plus our interest rate, 0.045, divided by 2, because we're talking about semi-annually. And then we're going to raise that to the 2, that's our n value, times 1, because we're just looking to do it for 1 year. Okay, now how do we enter this into our calculators? So let's pull out our graphing calculator, and we're going to enter in 1 times, and then we're going to open up our set of parentheses, and we're going to say 1 plus, and now we're going to open up another set of parentheses and do our 0.045 divided by 2, close one set of parentheses. Now we can close the second set of parentheses, and we're going to raise that to the 2 times 1, which is just 2. So we can go ahead and hit enter, and the result we get here is 1.0455. So if I'm going to come back over here to my notes, this is going to come out to 1.0455. Now if I change this back to a percentage, what I'm looking at is I'm just looking at this 0.0455, and as a percentage this comes out to be 0.455%. All right, now what happens if we calculate this daily? So we're going to take the n value here to be 360 for daily, and let's go back to our graphing calculator. Now here's a little trick. If we already have our equation from the first one entered in, all we need to do is change our value for n. So we're going to hit second function and enter, and that puts our equation back on the line. So we're going to come over here to where 2 is entered, and now we are going to delete the 2, and we'll hit second function delete to insert. 360 is going to be our number that we'll choose for this one, and then a cursor over, I'll hit delete on the 2 here, and I'll enter 360 here as well and press enter. And now my percentage rate is 1.046. So if I come back here to my notes, I now get the same 1.046, which as a percentage is now 4.6%. All right, for monthly now, my value for n is 12, and my equation would look like this: 1 times 1 plus, and then parentheses, 0.0455 divided by 12, all raised to the 12 times 1 power. So let's go back to our graphing calculator. We'll hit second function, enter. We'll get that same line back up there. We're going to cursor over to where it says 360. We're now going to replace that with 12. And we're going to cursor over here to the other 360, enter in the value for 12. Oops, we got to delete that 0. And when we press enter, and we now find out what our percentage rate, our APY, would be for something that's compounded monthly. So now we get 1.0459. As a percentage, we're going to move our decimal over 2 places. This gives us 4.59%. All right, let's take a look at example 2. Example 2 says to find the amount in an account that's earning 9% interest compounded annually after 8 years if $3,000 is invested initially. So the $3,000 represents P, our principal. 8 years represents T, the time it's compounded. Our rate, 9%, is going to be 0.09 as an interest rate, and we recognize that it's annually compounded. So we're just going to use our annual compound formula, which says the 3,000 times 1 plus our interest rate as a decimal raised to the t power, which is the number of years, which is 8. So we're going to plug that into our calculator. When we do that, we get 3,000 times 1.09 to the 8th power, and this is going to result in $5,977.68. So you can see in an account earning 9%, your money almost doubles in just 8 years. That's a ridiculously good interest rate. If you ever find anything growing at 9%, put your money there. That's good. All right, example 3 says Sully wants to save $7,000 in an account that earns interest. One account earns 3.5% compounded semi-annually, and another account earns the same rate but is compounded daily. How much more money will Sully have in his account after 3 years if he chooses to the account where it's compounded daily? All right, so we really need to calculate both of these. We're going to recognize that 7,000 is our principal. Our interest rate is 0.035, and then let's compare how much we have in both of those accounts. So let's do our semi-annually. We have 7,000 times 1 plus our interest rate, 0.035, divided by 2. And this is going to be raised to the 2 times 3 power because we're going to put it in there for 3 years, and it's compounded semi-annually. Now the other account is going to be represented by the formula 7,000 times 1 plus 0.035 divided by 360, let's use 365 this time, all to the 365 times 3 power. Okay, so let's go to our graphing calculators and let's see what our interest would be. In this case, we're going to enter in a new equation. We have 7,000 times 1 plus, and then we're going to open up a set of parentheses, and we'll do our interest rate, 0.035, divided by 2. We'll close that parentheses, close it again, and then raise it to the power. Now we're going to open up a set of parentheses, and we're going to say, actually for this one, we're not going to open up a set of parentheses. Let's just do to the 6th power. All right, when we press enter, we'll get our $7,767. $767.92. All right, now let's enter our other equation in, and we again can just use second function enter, and let's scroll back here to where it says 2, and we're going to hit delete, and second function insert 365, and then we'll move out here, and now we'll put in our parentheses, and we'll do 365 times 3. All right, and now we can press enter, and we'll get our new amount of $7,774. $74.93 or 94 cents. So you can see here the difference in these two accounts, how much more is Sully going to make based off of choosing the daily compounded interest. Well, what we need to do is we need to subtract these two, so 7,774.93, and we're going to subtract 7,767.92, and that comes out to a whopping $7.02. So the compounding amounts don't make a huge difference, but they make a little bit. All right, let's move into example 4 here. We have a bond that's paying 7% interest. It's compounded annually, and it has matured. Well, that means that it's kind of come due. It's ready to be withdrawn now. And it gives the owner $10,000. In other words, this is the amount that it's worth. How much was invested 8 years ago? So in this case, we want to find the principal amount. Well, our interest rate is 0.07, and it's been in there for 8 years. So let's work backwards to see if we can find out the initial amount that was invested. $10,000 is equal to the principal times, it's compounded annually now, so we're just going to use our 1 plus 0.07 to the 8th power. Well, 1 plus 0.07 can be written as 1.07 to the 8th power times P is equal to 10,000. Now, in order to get P by itself, we need to divide both sides by 1.07 to the 8th. And when I take 10,000 and divide it by 1.07 to the 8th power, my principal amount comes out to be $5,820.09. All right. Now, in part B, it says, how many more years until this bond's original value doubles? Well, you can see here our original bond was $5,820. So we can write the equation A is equal to 5,820.09 times 1.07. And now we can have a variable of x, and we can put this into our y equals on our graphing calculator. And we're going to look at our table of values. So let's go to our graphing calculator. Let's go to our y equals, and we have 5,820.09 times our interest rate, or 1 plus our interest rate, so 1.07, and raise that to the x power. And now if we go to our table of values, we can see the number of years in our column of x's. And you can see here at 8 years, whoops, here's 8 years, it was 10,000, which was the original problem that we had. And what we want is when it's doubled. So we're looking for right around 11,600. So you can see right in here between the 10th and the 11th year, so maybe about 10.5 years it will take for this bond to double in its original value. All right. Example number 5 is very similar to the previous example. Why don't you pause the video now and see if you